Welcome. In this video, we'll take a closer look at another essential concept in Legos, namely calculated fields. We will discuss the role of calculated fields, and present some of the key features and benefits of making use of calculated fields on data objects. Calculated fields, also known as computed or derived columns, are special fields in a data object within Legos. Instead of storing static data, these fields derive their value from other columns in the table through a defined expression. This expression can involve various arithmetic operations, string functions, or more complex logic. The key feature of calculated fields is their dynamic nature. A calculated field's value is computed on the fly whenever it is queried, using the current values of the other fields in the table. This ensures that the calculated field is always up to date. Expressions are used to define calculated fields. These expressions can include a wide range of operations, such as formatting of dates, mathematical calculations, concatenation of strings, application of functions, and even conditional logic. This versatility allows for complex data manipulation directly within the database. Unlike regular fields, calculated fields do not store data directly in the database. Instead, their values are generated dynamically whenever needed. This reduces storage requirements and ensures that calculations are always performed with the most current data. Pushdown syntax is a technique that enhances SQL query performance by delegating the execution of queries to the underlying data source. Different data sources might have variations in their syntax, so it's important to understand where the query will be executed. When pushdown is enabled for a data object, the syntax should align with the underlying data source's syntax. If not, the syntax should conform to SQL 99 standards. Adding calculated fields to your data objects can provide several significant benefits. These include the ability to derive new information, ensure data integrity, simplify queries and reports, maintain consistency, enhance analysis and decision-making, and offer flexibility in data analysis. Calculated fields enable you to derive new information from existing data. For example, you might extract the month from a date field, calculate a total cost by multiplying a unit price by a quantity, or determine a person's age based on their birth date. This ability to derive information adds significant value to your data. By calculating values rather than storing them directly, calculated fields help maintain data integrity. If the underlying data changes, the calculated field automatically adjusts to reflect those changes, ensuring that your data remains accurate and up to date, without the need for manual updates. Calculated fields can simplify your queries and reports by pre-calculating values that are frequently used. This means that instead of performing complex calculations within each query, you can simply reference the calculated field, making your queries more efficient and easier to manage. Calculated fields ensure consistency across your dataset. By defining the calculation once and applying it uniformly to all relevant records, the risk of errors and inconsistencies that can arise when values are calculated manually is significantly reduced. Calculated fields can provide valuable insights for analysis and decision-making. For example, you might calculate profit margins, growth rates, or key performance indicators based on existing data. These insights can help you to make informed decisions and understand your data better. Calculated fields offer flexibility in data analysis. The fact that you can experiment with different calculations without modifying the underlying data gives you the freedom to explore various scenarios and hypotheses. Remember, you can also take an existing field and transform it into a calculated field. This flexibility is invaluable for in-depth data analysis and exploration. Now let's demonstrate some examples using the calculation builder provided in Legos. We will use datepart, concatenation, and case statements in newly created fields to demonstrate how to use the calculation builder effectively. First, modify the object and select the Fields icon on the canvas ribbon. The Fields modal will open. To add a calculation, you must first create a new field. Select the Create Field button. Add the attribute code. Remember, this field does not allow special characters. Add the field alias, and then select the Calculation Builder icon next to the expression field. The Calculation Builder modal will open. The fields list displays to the left, while the functions list displays on the right. This list provides functions in a predefined syntax based on the data source used. The canvas on which you build or write the calculations is located in the middle of the modal. In this first example, we want to extract the month from the invoice date field. To do this, you can either scroll through the functions list to find the available date functions, or alternatively, you can use the search field provided to search for it. Select, drag and drop the month function on the top of the canvas. The calculation will display on the canvas. Note the gray block with the word call. This means that the value here should be replaced by the relevant field. Select the gray block. Then select the invoice date field from the invoice entity. Note the calculation has been updated to reflect the selected field. Click the Apply button. The expression field on the Create Field modal now displays the calculation that was added. Scroll to the Frax's data type code field and select the N-varchar option. This field is a dimension, so the type does not need to be changed. Select Save. The new field has been added to the fields list. Close the modal. Validate the object. In this instance, push is active on this object. The federated and data source queries display, with the new field calculation included. Close the validation results and run the data object. The new invoice month column is present in the run results. In this next example, using the concatenation function and the instructions provided in the previous clip, you will concatenate the first and last name fields from the customer entity. From the fields list, you will create the new field and open the calculation builder. This time, search for, select, and then drag and drop the concatenation function onto the canvas. Replace the gray function fields with the first name and last name fields from the customer entity. In this instance, you want to add a space between the names, so in the bottom section of the canvas, you manually add the additional text to the calculation. Select the Apply button. From the Create Field modal, select the relevant data type. In this instance, N-varchar. Then save and close the fields list. Validate the object and confirm the run results. Lastly, let's have a look at how to use a case statement with the country field, which currently displays the full country name, to provide you with the country codes for the European countries, or alternatively, use the value other for any other non-European countries. You will note that there is no case function provided in the functions list. This need not be a concern, as you are also able to manually input a calculation. In the case statement being used in this example, you will note that where the country is a European country, you are asking for the country code to be represented, and where it is not, you want to use a value of other. Apply the calculation, select the Frax's data type code, which in this case is N-varchar. Select Save, then close the fields list. Validate the object. Run the object and view the results. In conclusion, adding calculated fields to your data enhances its value by providing additional insights, improving data integrity, and simplifying data analysis and reporting processes. By leveraging calculated fields, you can make more informed decisions and ensure that your data is both accurate and useful. Thank you for watching. Catch you in the next one.